Organizing quantitative data. Terms used in limit grouping. Lower class limit, the smallest value that could go in a class. Upper class limit, the largest value that could go in a class. Class width, the difference between the lower limit of a class and the lower limit of the next higher class. Class mark, the average of the two class limits of a class. Example, determine a frequency distribution. A simple quantitative data set has been provided. Use limit grouping with the first class of 0 to 4 and a class width of 5. We have a data set of 25, 26, 17, 3, 9, 1, 19, 22, 22, 13, 0, 4, 12, 19, 16, 27, 22, 11, 17, 23, which is 20 pieces of data. Our table is broken up into class and frequency. Our first class is already written, 0 to 4. To find the next class, we want to add the class width to the lower and upper limits. 0 plus 5 is 5, 4 plus 5 is 9, 5 to 9 is my next class. 5 plus 5 is 10, 9 plus 5 is 14. The third class is 10 to 14. 10 plus 5 is 15, 14 plus 5 is 19, so my fourth class is 15 to 19. 15 plus 5 is 20, 19 plus 5 is 24, so my next class is 20 to 24. 20 plus 5 is 25, 24 plus 5 is 29, the last class is 25 to 29. Now we want to figure out the frequency. In order to find the frequency, we want to see how many data points are in each class. So starting with 0 to 4 inclusive, I want to count up the data points that will belong in that class. I have 3, 1, 0, and 4. That's 4 data points, so my frequency is 4. Next, I want to find how many data points are in the class 5 to 9 inclusive. So that's going to include 9, and that's all. So that class has a frequency of 1. Next, I want to find the data points that fall in the class of 10 to 14 inclusive. I can count 12, 13, and 11. So that's 3 data points. My frequency is 3. For my next class, I have 15 to 19 inclusive. So I can count 17, 19, 19, 16, 17. Since that's 5 data points, my frequency is 5. Next, I want to count up the data points for the class of 20 to 24 inclusive. I have 22, 22, 22, 23. That's 4 data points, so the frequency is 4. My last class is 25 to 29 inclusive. I have 25, 26, and 27. That's 3 data points, so my frequency is 3. The total frequency should always equal your sample size. 4 plus 1 plus 3 plus 5 plus 4 plus 3 equals 20. And my data set is 20, so we haven't missed a data point. Terms used in cut point grouping. Lower class cut point, the smallest value that could go in a lower class. Upper class cut point, the largest value that could go in the next higher class, equivalent to the lower cut point of the next higher class. Class width, the difference between the cut points of a class. Class midpoint, the average of the two cut points of a class. Example, determine a frequency distribution. A simple quantitative data set has been provided. use cut point grouping with a first class of 44 to under 50. My data set has 20 data points, and they are 65.4, 53.9, 68.4, 46.7, 64.8, 58.3, 61.5, 55.1, 57.6, 44.7, 55.5, 50.7, 60.8, 72.3, 58.4, 48.1, 65.3, 50.2, 70.8, 64.3. Our first class is 44 to under 50. That means my second class will begin with 50. 50 take away 44 is 6. Since I have a class width of 6, 50 plus 6 is 56. The second class is 50 to under 56. 56 begins our third class. 56 plus 6 is 62. So my third class is 56 to under 62. 62 begins my fourth class. 62 plus 6 is 68. So the fourth class is 62 to under 68. I start my fifth class with 68. 68 plus 6 gives me 74. So my last class is 68 to under 74. Now I want to find the frequency for each class. Starting with 44 to under 50, I can use 46.7, 44.7, and 48.1. That's 3 data points, so my frequency is 3. My next class is 50 to under 56, so I can count 53.9, 55.1, 55.5, 50.7, and 50.2. That's 5 data points, so the frequency is 5. My next class is 56 to under 62, so I can count 58.3, 61.5, 57.6, 58.4, and 60.8. That's 5 data points, so I have a frequency of 5. For my next class, I have 62 to under 68. So I can count 65.4, 64.8, 65.3, and 64.3. That's 4 data points, so my frequency is 4. For my last class, I have 68 to under 74. I only have 3 data points for that, 68.4, 72.3, and 70.8. So that class has a frequency of 3. 3 plus 5 plus 5 plus 4 plus 3 equals 20. My data set is 20, so I have included all my data in my frequency distribution table. Example: obtain a relative frequency distribution. Using the frequency distribution that we just created, we are now going to find the relative frequency for each class. The first thing that you need is the total frequency, which we know to be 20. To find the relative frequency, you divide the frequency by the total. So for our first class, 44 to under 50, it is 3 divided by 20, which is 0.15. For my second class, 50 to under 56, it's 5 divided by 20, which is 0.25. 56 to under 62 also has a frequency of 5. 5 divided by 20 equals 0.25. The class 62 to under 68 has a frequency of 4. 4 divided by 20 is 0.2, or 0.20. The class 68 to under 74 has a frequency of 3. 3 divided by 20 is 0.15. Your relative frequencies should add up to 1. I can check my work by adding 0.15 plus 0.25 plus 0.25 plus 0.2 plus 0.15, and it does equal 1. Choosing the grouping method. So we have our different grouping methods and when to use in the table. Single value grouping. Use with discrete data in which there are only a small number of distinct values. Limit grouping. Use when the data are expressed as whole numbers and there are too many distinct values to employ single value grouping. Cut point grouping. Use when the data are continuous and are expressed with decimals. Histogram. A histogram displays the classes of the quantitative data on a horizontal axis and the frequencies or relative frequencies or percents of those classes on a vertical axis. The frequency, relative frequency, or percent of each class is represented by a vertical bar whose height is equal to the frequency, relative frequency, or percent of that class. The bars should be positioned so that they touch each other. Histogram. For single value grouping, we use the distinct values of the observations to label the bars, with each such value centered under its bar. For limit grouping or cut point grouping, we use the lower class limits, or equivalently lower class cut points, to label the bars. Note, some statisticians and technologies use class marks or class midpoints centered under the bars. And here's an example of just a random histogram, just so you can see what it looks like. For this histogram, we have 6 bars. The first bar, the lower limit, is -2, then -1, 0, 1, 2, 3, and 4. Then along the vertical axis, it starts at 1 and goes up to 1.4. To construct a histogram, Step 1. Obtain a frequency, relative frequency, or percent distribution of the data. Step 2. Draw a horizontal axis on which to place the bars and a vertical axis on which to display the frequencies, relative frequencies, or percent. Step 3. For each class, construct a vertical bar whose height equals the frequency, relative frequency, or percent of that class. Step 4. Label the bars with the classes, the horizontal axis with the name of the variable, and the vertical axis with frequency or relative frequency or percent. Example. Construct a frequency histogram based on the frequency distribution for the following set of data from the earlier example. So we are using the frequency table with the classes 0 to 4 with a frequency of 4, 5 to 9 with a frequency of 1, 10 to 14 with a frequency of 3, 15 to 19 with a frequency of 5, 20 to 24 with a frequency of 4, 25 to 29 with a frequency of 3. First, we want to draw our axis. Our horizontal axis is labeled class, and our vertical axis is labeled frequency. For our horizontal axis, we are listing 0, 10, 20, and 30. When you list your numbers on your horizontal or vertical axis, they need to be the same increment. For the vertical axis, we have 0, 6, and 12 at our major hash marks. The minor hash marks are by ones. So I start with 0, have 1, 2, 3, 4, 5, then I get to 6, 7, 8, 9, 10, 11, and then get to 12. Then we draw our bars. So I have a bar that starts at my lower limit for my first class, then a mark at 5, 10, 15, 20, 25, and then it ends with 30. The frequency determines the height of the bars. My first bar has a height of 4, the second has a height of 1, the third has a height of 3, the fourth has a height of 5, the fifth has a height of 4, and the sixth has a height of 3. With a histogram, it's very easy to see your greatest frequency and your lowest frequency. Example: construct a relative frequency histogram based on the relative frequency distribution for the data set from the earlier example. We're using the example with the decimals. Our first class was 44 to under 50 with a relative frequency of 0.15, 50 to under 60, 0.25, 56 to under 62, 0.25, 62 to under 68, 0.2, 68 to under 74, 0.15. We want to start with our two axes. My horizontal axis is labeled class, and my vertical axis is labeled relative frequency. Again, my hash marks are the lower class limits. I have 44, 56, and 68. Then on my vertical axis, I start at 0, and each hash mark is 0.05. So I have 0.05, 0.1, 0.15, 0.2, and then it's labeled at 0.25, 0.3, 0.35, 0.4, 0.45, and then it's labeled at 0.5. Now I'm ready to draw my bars. Again, the bars are touching. The relative frequency is the height of each bar, so my first bar has a height of 0.15, my second bar has a height of 0.25, the third bar has a height of 0.25, the fourth bar has a height of 0.2, and the fifth bar has a height of 0.15. Dot plot. A dot plot is a graph in which each observation is plotted as a dot at an appropriate place above the horizontal axis. Observations having equal values are stacked vertically. Here's an example of a dot plot. We have a number line from 0 to 18, increment of 1, which means it was 1, 2, 3, and so on. Then we have our dots for our data above each number. The nice thing about a dot plot is I can easily find my highest and lowest frequency, but still see the individual pieces of the data. To construct a dot plot, step 1, draw a horizontal axis that displays the possible values of the quantitative data. Step 2, record each observation by placing a dot over the appropriate value on the horizontal axis. Step 3, label the horizontal axis with the name of the variable. Example, create a dot plot of the data. A simple quantitative data set has been provided giving the price in dollars of 16 DVD players. My data points are 210, 224, 208, 212, 219, 219, 209, 212, 214, 199, 215, 219, 197, 199, 199, 210. First, I want to draw my number line. I'm starting with 190. I have minor hash marks at 1s, and my major hash marks I'm marking by 10s. So I have 190, 200, 210, 220, and 230. The name of my data, price, in dollars, goes underneath, and the title of my graph, prices of DVD players, goes above. Now I want to take each data point and plot it above my number line. What we need to do is every first piece of data needs to line up in a straight line, every second piece of data needs to line up in a straight line, and every third piece of data, and so on, need to be in straight lines. Otherwise, it'll be difficult to see your frequencies. So I'm going to start with the first column, and I have a dot for 210, then a dot for 224, a dot for 208, a dot for 212. Now I'm going to the second column of data. I have a dot for 219, another dot for 219, which goes above, making my second row, a dot for 209, and another dot for 212. Moving to the third column of data, I have 214, 199, 215, 219. Moving to my final column, I have 197, 199, 199, and 210. Again, it's similar to a histogram with the height of the columns. However, I can see all of my individual data points, whereas that's not available with the histogram. Stem and leaf diagrams. In a stem and leaf diagram, or stem plot, each observation is separated into two parts, namely a stem consisting of all but the rightmost digit and a leaf, the rightmost digit. Here's an example of what a stem and leaf diagram can look like. All the numbers in the column to the left represent my stem. All the numbers to the right represent the leaf. To read this, I'm going to use the row with the 6 to read our data. So I have 6 and then a 9. That's 69. 6, then 8 gives me 68. 6, then 9 gives me 69. The bottom row, I have 10 and then a 0 and another 0, which means I have two data points that are 100. To construct a stem and leaf diagram, Step 1. Think of each observation as a stem, consisting of all but the rightmost digit, and a leaf, the rightmost digit. Step 2. Write the stems from smallest to largest in a vertical column to the left of the vertical rule. Step 3. Write each leaf to the right of the vertical rule in the row that contains the appropriate stem. Step 4. Arrange the leaves in a row in ascending order. Example: create a stem and leaf of the data. The data represents the days to maturity for 40 short-term investments. My data set consists of 70, 62, 75, 57, 51, 64, 38, 56, 53, 36, 99, 67, 71, 47, 63, 55, 70, 51, 50, 66, 64, 60, 99, 55, 85, 89, 69, 68, 81, 79, 87, 78, 95, 80, 83, 65, 39, 86, 98, 70. Our smallest data point appears to be 36, and my largest data point appears to be 99. So when I create my stem and my leaf, I have my vertical line. I want my stems to be 3, 4, 5, 6, 7, 8, 9, each representing a tens. So it represents 30, 40, 50, 60, 70, 80, 90. Now I want to add the leaves. So I'm going to begin with my 30s. I have 36, 38, and 39. Putting those in numerical order, I get 6, 8, and 9. Next, I'm going to move to my 40s, which is 47. So I just write 7. I'm keeping my columns lined up so that I can easily see my greatest and lowest frequencies. Next, I'm moving to my 50s. I have 51, 57, 53, 56, 50, 51, 55, and 55. Putting those in numerical order, I have 0, 1, 1, 3, 5, 5, 6, 7. Next, I'm going to do the 60s. I have 62, 64, 63, 67, 66, 60, 64, 69, 68, and 65. Putting those in numerical order, I have 0, 2, 3, 4, 4, 5, 6, 7, 8, 9. Moving to the 70s, I have 70, 75, 71, 70, 79, 78, and 70. Putting those in numerical order, I have 0, 0, 0, 1, 5, 8, 9. Now I'm going to move to the 80s, which is 85, 81, 89, 87, 80, 83, and 86. Putting those in numerical order, I have 0, 1, 3, 5, 6, 7, 9. Now I'm ready for my 90s. I have 99, 99, 95, and 98. In numerical order, that gives us 5, 8, 9, 9. So it's easy to tell that my 60s have the highest frequency and my 40s have the lowest frequency. Again, this has the benefit of a histogram where I can see the height of my frequency, and it also has the benefit of me being able to see all of my data points. Example, create a stem and leaf of the data. The data represents the cholesterol levels for 29 high-level patients. The data, 210, 217, 208, 215, 202, 209, 207, 210, 221, 218, 212, 210, 210, 213, 200, 208, 203, 199, 218, 214. So this time when we create our stem and leaf, we're going to use 2 digits. 19, 20, 21, and 22. First, I want to look for all the numbers in the 190s. I only have 199, so I write 9. Now I'm looking for all the numbers in the 200s. So I have 202, 208, 207, 209, 200, 203, 208. Putting those in numerical order, I have 0, 2, 3, 7, 8, 8, 9. Now I'm looking for numbers in the 210s. I have 210, 217, 215, 210, 218, 213, 210, 210, 212, 214, 218. Putting those in numerical order, I have 4 zeros, 2, 3, 4, 5, 7, 8, 8. My only number that is left is 221, so I just want to write 1. To recap the section, organizing quantitative data. Limit grouping. This is a way to group your data when your data is whole numbers. Cut point grouping. This is a way to group your data when you have decimals. Histogram. This is a way to show your grouped data pictorially using bars. I can use either percentages, the relative frequency, or the frequency for my vertical axis. Dot plot. The dot plot uses dots above a number line to show our data. It has the advantage of a histogram and also the advantage of seeing all of our original data. Stem and leaf diagrams. The stem and leaf diagrams divides our data in a stem and a leaf. The leaf is always the ones digit and the stem is the rest of the numbers. It can be 1 digit, 2, 3 digits, depending on your data. Again, it has the benefit of a histogram while allowing us to also see all of our data points.